Hello, my name is Sam, I'm an online maths tutor and this is a video about second derivatives. This is an A-level video and it will employ the Year 12 methods for solving derivatives. Okay, so let's start straight away. So I've got three graphs shown here. Well, one graph with three lines. I've got y equals x cubed, y equals 3x squared and y equals 6x. So we're starting with y equals x cubed is the red curve, and y equals 3x squared is the first differential of y equals x cubed, and then y equals 6x is the first differential of y equals 3x squared. Now if you do this first differential operation twice, where you differentiate y and then you differentiate y again, that's what's known as a second differential. And so in this case, y equals 6x is the second differential of y equals x cubed. To write this, we would say that dy by dx is equal to 3x squared, and d squared y by dx squared is equal to 6x. It's important that the square is on this first d and that the square is on the x here. dy squared over d squared x or whatever it is does not mean the same thing. It is going to be d squared of the variable that you are differentiating over d and then the variable with respect to squared. And that's where we get this term from. So d squared y over d squared x equals 6x. If you're going to write this in a function form, you can have f of x equals some function of x. F dash of x is the first differential, and f dash dash of x is the second differential, where you have differentiated twice. I realize you can't see that there from the face cam, but the double dash there is the second differential. Okay, so what does this actually mean? Well, the second differential is where you have differentiated your first differential. So what does the first differential mean? Well, it's the rate of change of a function with respect to a certain variable. In the case of y equals x cubed, it's the rate of change of the variable y as you change x. Essentially, it is the gradient at any point on the curve, and you can use 3x squared to find the gradient of x cubed at any point on the curve x cubed. Now the same thing goes for the second differential. This time you're just using the first differential as your original curve. So if you differentiate 3x squared again, 6x will tell you the gradient of that line at any point on it. A good way of thinking about this is by using these using the three equations which we have going on here, where we're saying that this blue curve is the differential of the red curve, and the green line is the differential of the blue curve. We can see that as the blue curve comes from positive with a negative gradient, the gradient is slowly increasing at a linear rate until it reaches 0. And we can see that reflected in the green line. The green line starts negative and it increases at a linear rate before it reaches 0. And y equals 6x is 0 at the same time that the gradient of y equals 3x squared is 0. And the same goes for y equals 3x squared is 0 at the same time that x cubed is 0, since the gradient is 0 at the origin on x cubed. So that is the second differential, and that is what it means. It is the rate of change of your first derivative. And it's another way of thinking about it is the rate of change of the curvature of a curve. So it'll tell you, is a curve curving downwards or is it curving upwards? And this can be very useful. So here we have another curve. So this is a quadratic curve. I believe it's 2x cubed plus 2x, I'm not sure. But a second differential tells you, is a curve curving up or down? So if you think that it calculates the derivative at any point, if the derivative is positive, that means that you are curving upwards. If the derivative is negative, it means you are curving downwards. And so if your second differential is less than 0, it means that you are curving downwards. And if your second differential is greater than 0, it means you are curving upwards. It means your gradient is increasing. And so we can see that shown here on this graph, and we can actually use second differentials to determine if a root that we find or if a turning point that we find is going up or is going down. So here at this top curve, at this top point, the differential at this point is going to be equal to 0. So we know that it is a stationary point on this curve. However, we don't know if it is going up or if we are going down purely algebraically. The way that we can do that is by using the second differential. If the second differential is less than 0, it means that the rate of change of the gradient is negative. The gradient is decreasing, which means that it is curving downwards. As opposed to that, at this point, the rate of change of the gradient is positive. You started at a low point, but the gradient is getting larger. Therefore, you know that you are going upwards. Therefore, some point in between these, the gradient must be zero. Not the gradient, but the rate of change of the gradient must be zero. Since if your gradient is decreasing and then your gradient is increasing, there must be a point in the middle where there is no change happening. And that is this point in the middle, which is called a point of inflection. It is where the gradient goes from changing downwards to changing upwards, or from changing upwards to changing downwards. And it can show you the point where a curve goes from moving down to then moving upwards. So it's quite useful. And we're going to take a look at an example question now. So this is our first question which we are going to have a look at. It is asking for the second differential of x when f of x is equal to 3x cubed plus 6x squared minus 2x minus 4. And it is asking us to determine if the first stationary point of this equation is a minimum or a maximum point. So let's start by finding our first and second derivatives. So f of x is equal to 3x cubed plus 6x squared minus 2x minus 4. And the first derivative, we're going to use the power rule. So we multiply by the power and drop the power by 1. We're going to multiply by the power again, drop the power by 1. Multiply by the power, drop the power by 1. So this becomes a 0, which eliminates the x. And then we can forget about the minus 4, as it does not have an x term on it. We can then differentiate again to get f dash dash of x being equal to 9x plus 12. Sorry, not 9x plus 12, 18x plus 12. So now we have our first and second derivatives. So the first part of the question has been answered. We have found our first derivative, 18x plus 12. We now need to determine if the first stationary point of this equation is a minimum or a maximum point. So how do we find a stationary point? Well, a stationary point occurs when the gradient is 0. So when f dash of x is equal to 0. So we are going to look for where 9x squared plus 12x minus 2 is equal to 0. And we can use a calculator to solve this. We find that our roots of this equation, so where this equation is equal to 0, it goes that x equals minus 2 plus or minus the square root of 6 all over 3. Now that is some long, horrible decimal number, but it's important to note that if you're going to have a number like this and you're using it in an exam, you should save that value to your calculator memory. Okay, so how do we find if this equation is if this stationary point, so at x equals this, is a minimum or a maximum point? Well, we need to find the coordinate at which this occurs. So the coordinate on this graph at which our gradient is 0 is equal to this x value here, and we need to determine if at this x value or at one of these x values, our value for the second derivative is higher or lower than 0. So like I said earlier on in the video, if we have a maximum point, the second differential is going to be less than 0, and if we have a minimum point, the second differential is going to be greater than 0, as in each of those cases the gradient is changing going down or changing going up respectively. So we're going to calculate the first stationary point. So the first stationary point will occur at the lowest value of x here. So we're going to take minus 2 minus root 6 over 3. So we're going to do f dash dash of minus 2 minus root 6 all over 3, and we're going to calculate that value. That's equal to 18 times this plus 12, which is going to be 6, since the 18 and the 3 can cross cancel to become 6, since 6 times 3 is 18. Times by minus 2 minus root 6 plus 12. This is equal to minus 12 minus 6 root 6 plus 12, which is equal to minus 6 root 6. So I didn't need a calculator to work that out, you can just do it in your head. And minus 6 root 6 is less than 0. Therefore, our second differential is less than 0 at the first stationary point. Therefore, since it is less than 0, we know that the gradient is decreasing, so this is a maximum point. Fantastic. Let's move on to a second example. This time we are just calculating the second derivative. This is just some more practice on calculating second derivatives with some harder fractions, but this shouldn't be too tricky. So firstly, let's write out our function. So 6 over x cubed, so this is equal to 6 over x cubed minus a half x to the power of 4 minus 9x. Now I'm going to rewrite this. I don't like having the variable here on the denominator. That just makes things uglier and harder to deal with. So I'm going to rewrite this as 6x to the minus 3 minus a half x to the power of 4 minus 9x. Having everything set out in the same way makes it much easier to deal with them, as you're just doing the same thing to all of the powers. So let's multiply by the power, so this is going to become minus 18x, drop the power by 1, so it becomes a minus 4. Multiply up by the power, it gives us minus 2x, drop the power by 1, cubed, multiply by the power is 1, drop the power to 0, and the x disappears. And this is our second differential f dash dash of x, where this is f dash of x. Thank you for watching. I hope this has been informative. If you liked, please do like the video or subscribe, and do send me an email if you are interested in online tutoring. Thank you.